Hello everyone. So in this video we are going to learn about the Nernst equation. Now first I would like to explain the meaning of the term galvanic cell. Okay, because you need to understand the meaning of galvanic cell, then only you can understand the purpose of Nernst equation. Okay, so what is a galvanic cell? Galvanic cell is a cell which converts the chemical energy of a redox reaction. Okay, some redox reaction will happen inside the cell. So the chemical energy of the redox reaction would be converted into the electrical energy. Okay, electricity you will get at the cost of some chemical reaction. Okay, so, for example, if you take the reaction between zinc and copper ion, so you can see that this reaction will happen like this. So, zinc is getting oxidized and copper is getting reduced. So, copper is getting reduced and zinc is getting oxidized. So, this is a kind of redox reaction. So, when this reaction will happen inside the cell, so you will be getting the electrical energy. That means electricity you will get. Or you can say you will get the potential. Potential means voltage. Okay, so you get the electrical potential. So this electric potential is called as the cell potential. So cell potential is what? That is the output which you get out of the cell. When the cell is working, when the galvanic cell is working, then from the galvanic cell you get the cell potential. Okay, now cell potential, it is of two types. One is E cell and another is E naught cell. Now, what is the basic difference between these two? This E cell is the normal cell potential, whereas this E naught cell is the standard cell potential. Okay, always remember that this is the standard cell potential. In case of standard cell potential, the concentration of the solution would be taken 1 molar. Okay, and temperature is taken 298 Kelvin. Fine. Now, in case of E cell, you will take the concentration of the solution which is not equal to 1 molar. Okay, so when the concentration of the solution is taken 1 molar, in that case, E naught cell we calculate, and when the concentration of solution is not equal to 1 molar, then we use the term E cell. Fine. Now, if I tell you that in the same reaction between zinc and copper ion, if I mention that the copper solution concentration is X and zinc solution concentration is Y. Okay, and these X and Y, they are not equal to the 1 molar concentration. So in this case, I need to calculate the E cell. Why E cell? Because the cell concentration, the solution's concentrations are not equal to 1 molar. Fine. So for calculating the E cell, I will be using this equation which is called Nernst equation. So this is the Nernst equation. It is written as E cell is equal to E naught cell minus 0.059 upon N log product concentration upon reactant concentration. And in the concentration terms, you have the power A and B. So these powers A and B, they are actually the coefficient of the concentration terms in the reaction. Fine. Or in case the concentrations are not involved in the reaction, rather the gases are involved and the pressure is given, then you will use the pressure of the product and the pressure of the reactant. Fine. So this is the Nernst equation. So this Nernst equation is used to calculate the cell potential. Okay. Now, one thing which you should know about this Nernst equation is that this 0.059, this 0.059 is actually equal to 2.303 RT. upon F. Okay, so when you substitute the values R, of R and T, for example, R value, you know, it is 8.314, and temperature you will use 298 Kelvin, and F is a Faraday constant which is 96500. So when you substitute all these values of R, T and F and you multiply it with 2.303, finally you will be getting 0.059. Okay, so this equation is called the Nernst equation. This equation which I have written in the box, this is the final Nernst equation, the simplified form of Nernst equation which is used in doing the numericals. Okay, but the actual Nernst equation, if you want to write, then it is not just 0.059. You should be knowing that this 0.059 has been derived from 2.303 RT upon F, and in this case the temperature is always taken 298 Kelvin. Okay, so when you change the temperature from 298 to something else, then you will not be getting this value 0.059. Okay, now we will do the numericals based on this Nernst equation. So this is a question of JEE 2011 which is based on Nernst equation. So let's read the question. In this question, you are given a chemical reaction and E0 cell is given. Okay, the concentration of ferrocene is 10 raised to power -3. Pressure of oxygen is given 0.1 and pH is given. Okay, so instead of giving the concentration of H plus ion, in the question you are given the pH. And the cell potential you have to calculate at 25 degrees Celsius, that means 298 Kelvin. Okay, so first I will write the Nernst equation. As I have told you that Nernst equation is E is equal to E0 cell minus 0.059 upon N log. So you have to write the product upon reactant concentration. In the product side, you can see which ions are involved. Ferrous ions are involved. So you will write the concentration of ferrous ions. In the numerator, you will write the concentration of ferrous ions. Why? Because they are the product. Divided by. In the denominator, you have to write the concentration of reactant term. Okay, the ions which are given in the reactant side. So in the reactant side, you are given H plus ions. So H plus ions you will write like this. Okay, so concentration of H plus ions are written in the denominator. Also, in this question, you are given the pressure of oxygen as well. So oxygen is written on left hand side of the chemical reaction. So you will write the pressure of oxygen in the denominator. Okay, so always remember whatever is given in the product side is to be written in the numerator, and whatever concentrations or the pressure given to you in the left hand side of the chemical equation, so you will write that in denominator. Okay, product in the numerator and the reactant in the denominator. Okay, now I have to write the power also using this chemical equation. So this balanced chemical equation shows that ferrous ions concentrations are 2. Okay, so you will use 2 as a power. Similarly, H plus ion concentration, that is 4. That means you will use 4 as a power. Okay, now oxygen, in case of oxygen, there is no coefficient given, so you will not put anything in the power. Okay, now one thing which is missing in this question is the H plus ions concentration. Okay, you can see that ferrous ions concentration given, pressure of oxygen also given. Okay, number of electrons transfer, that is also given. You can see that on left hand side there is charge on iron is 0, and on right hand side the charge on iron is 4. That means there is an increase in 4 charge. Okay, unit 4 has been increased. It means the number of electrons transferred would be 4. So N is given, ferrous ions given, pressure given, only H plus ion concentration is missing. So how you will get it? You know the formula that pH is equal to negative log of H plus ions concentration. Okay, that means H plus ions concentration would be the negative anti-log of negative of pH. Okay, negative of pH. Now what pH is given? It is given 3. So that means you will take the antilog of -3. Now antilog of -3 is what? That is 10 raised to the power -3. So this is how you have calculated the H plus ions concentration. Now you will put the values, all the values which are given. E naught is 1.67 minus 0.059 upon N is 4 log ferrous ions concentration 10 power -3 whole square. H positive is what? That is 10 raised to the power -3 whole 4, and pressure given to you, it is 0.1. Okay, so when you solve this equation, you will be getting the final answer as 1.567 volts. Okay, so this is how you will calculate the E cell. So here E cell is calculated in this way. Okay, so these questions are very simple to understand. If you understand the topic to the core of it, then you can crack any question. Okay, so keep practicing these kind of questions. All the best, my dear children. Thank you.